Hi everybody. Okay, so this is going to be our chapter 1, section 3, final lecture video, an introduction to the periodic table. And here we see our first example of some different elements and their current modern names. Don't worry too much about the older names. Older names just kind of introduces you to how we got some of the names we currently have. They have changed over time. So for instance, tin down here is now has the symbol that matches its original name, but for modern times we've changed it to a simpler name, which is tin. Okay, this kind of gives you an example of like why tungsten, which starts with a T, does not have a T in its symbol on the periodic table. Instead, it's named after its old name, the wolfram. From there, I want to talk about basic regions of the periodic table. I'm going to ask you questions about this, so please make sure you're paying attention. You're going to be asked about this a lot. And the first big region that we want to discuss is going to be this one with all the red. I'm just going to change the color of my cursor real quick. It's not a great color. Alright. So we can see that this part of the periodic table, along with down here, this is about 2/3 makes up of the periodic table makes up metals. Okay, so about 2/3 of the periodic table, about 2/3 of the known elements in the universe are metallic in nature. Next, we have the metalloids, which are these orange compounds, also known as the semi-metals in some circles. These are going to be the kind of barrier between the metals and the non-metals. From there, we've got the non-metals, sorry, just kind of labeling, which are all in green. They kind of form this triangle. These are non-metals, and we're going to talk about the properties of each in this video. But for now, I just want you to notice that this is like general anatomy of the periodic table. And then last, but certainly not least, we have the noble gases, and we'll talk about what makes them unique here at the end. But just kind of understand that there are 4 major regions of the periodic table. We deal with those 4 on a regular basis. We will be talking about the properties of each here soon. Before we do so, we want to talk about general anatomy of the periodic table. First is going to be when we go up and down, right? These are vertical columns. These are referred to as groups. The older version of them was families, but for us, we just talk about groups. We'll talk about group 1, group 2, group 17, group 18. We'll talk about them in terms of similarities of properties. So the reason they are in these groups is due to their chemical properties that they have in common. The next thing we want to talk about is the across is going to be a period. Okay? When things are arranged in that horizontal row, we call that a period for a reason. These things are not going to have anything in common as far as properties. They change as you move across. But the big reason why they are in this is as you move from left to right, our atomic number changes by 1 as you go. Okay, so that's how we've arranged them in terms of periods. And we'll see examples of this here in the near future. Here's your first set of questions. There are a total of 6. Please label them on your sheet of paper as lecture questions 1, 2, 3, 4, 5, 6. I'm going to put 3 on this slide, and I'm going to put 3 on the last slide that we'll see for this video. So go ahead and pause it, answer the questions. This is generally asking you to look at a periodic table that has names on it and answer some questions. If you don't have one nearby, there are some in my classroom up on the cart, the black cart in the little pink like holders, and they are laminated. So you're welcome to borrow them. Just please put them back when you're done. When you're ready, go ahead and move on. All right, so let's talk about these different types of elements, and let's talk about what characterizes them. Again, this is probably something you know, which is why it's a good chapter to start with. A metal is going to be considered anything that is a good conductor and a good heat conductor. Both electrical and heat conductivity are major characteristics of metals. Some other very common properties of metals are listed down here. So we've got typically that they are solids at room temperature. We've got that they are malleable, aka they are able to be formed into different shapes. Ductility, remember we talked about that as the ability to be drawn into a wire. and they are good conductors of both heat and electricity, either good or bad depending on what you're intending to use them for. One of the things to note, on my periodic table in the room, there are red, there are black, and there are blue elements. Okay? Let's talk about what each one of them means. Red means that it's a gas at room temperature. Black means it's a solid at room temperature, and blue means it's a liquid. So this is the very large one to your left if you're in my room, on the wall, okay? And this is just all at room temp, these three. From there, we're going to talk about the different properties of those things, but just kind of keep this in mind. There are only 2 blue elements on the periodic table. There's bromine, which is a non-metal, and there's mercury, which is a metal, okay? So examples of some of the metals, we've got gold, copper, and aluminum here. All of them are metals at room temperature, meaning they are good conductors of electricity heat, just like what we said. Able to be drawn into a wire. This is kind of important for copper, for sure, because it's what we use to conduct electricity in our homes. And then we've got aluminum, which is obviously very malleable. You've seen this before. Aluminum foil, also sometimes called tin foil, used to be made out of tin, now made out of aluminum. All right, some of the non-metals have opposite or opposing characteristics of metals. These are going to be elements that are poor conductors of heat and electricity, but they tend to be decent insulators. So these are going to be typically in the gas form, and we'll see some that are in the gas form on the periodic table. Most of them are in the gas form. I think there's only 2 or 3 that are not. They are brittle, meaning they break easily. Okay, so they're not ideal for making solid structures, if you will. And instead of being good conductors, they're good insulators. Okay, so they are good at insulating from like heat or from cold and things of that nature. All right, some examples are things that are in the powder form. We've got carbon on the left. We've got sulfur after that, phosphorus, and iodine. All of these are typically pretty easy to break apart. They have their uses in a lot of the non-metals. One other characteristic to add, a lot of these non-metals are the basis of life. Okay, so we'll talk about oxygen, we'll talk about carbon, we'll talk about hydrogen. They're all very important. One of the things to note is that they are typically found in life-containing compounds. Okay? Our next type is going to be the metalloids. This is not the last type. These are going to be elements that have shared characteristics of both metals and non-metals. Sometimes they are referred to as semi-metals, which I feel like is a better indicator of what they are. They're kind of metals, but kind of not. They're solids at room temperature. This is a big property that we want to make sure we know. And sometimes they're like, I'm going to say meh at conducting electricity and heat. Meh is a very good descriptor of what these metalloids are. A lot of times our metalloids are very useful in electronics because they're kind of like switches. Like, we can turn them on and off as far as their semiconducting or their conducting abilities are concerned. So a lot of times we'll find silicon is one of our most famous metalloids, is useful in different like conductivity parts, if you will. Next up is going to be our last type of noble gases. One of the questions I'm going to ask you is, why are noble gases special? And the answer is they are really not. They are inert. They do not react. They're special in that they do not react with anybody else. Inert gases, so we say they're unreactive. The term inert, I-N-E-R-T, implies they do not react with other things. This can be super useful if we have something dangerous, useful for containing dangerous compounds, and control. So in experimental settings, a lot of times we will do reactions under helium to control the rate of the reaction, and or to control how large the reaction gets. If we did it in oxygen, a lot of times some things are very, very caustic and can just explode upon contact with oxygen or with water and so on and so forth. So doing them under an inert gas makes it so that that explosion or outside of the reaction will happen. These are all in group 18, which is the final column of the periodic table. And I'll show you another periodic table and point out some of these different things. And they are all gases. They're called the noble gases because they're all gases. Everybody in the periodic table, another reason they are safe, everyone wants to be a noble gas. And we'll talk about this theme throughout the year, but everyone wants to be a noble gas is a common theme that we'll come back to. Everybody wants to gain electrons to become the noble gas configuration. Everybody wants to lose electrons or get to a point where they have similar electron configurations of a noble gas. Again, we'll talk about what that means over the course of the year. So just kind of pointing out those regions again. You've got your metals. We've got our non-metals. Remember we talked about silicon. We've got our, I'm sorry, these are our non-metals. These are our metalloids in that center. And then here are our noble gases. Okay? All right, so some of the questions I'm going to ask you next are going to ask you to kind of identify properties and using the groups and periods types of stuff on a periodic table. All right, so here are your last three questions, kind of describing some of the different characteristics, properties, where, give me some information about those noble gases that we just talked about. And then you are done today. Go ahead and upload your questions when you are done to our Canvas site. Have a great day. I miss you all. See you soon.